Hello, Honor Chem students. Mrs. Snyder here. Just want to do a video about colligative properties and vapor pressure. This is a gizmo called Colligative Properties that has a pretty sweet animation here that shows a container of water. It's a sealed container that has a thermometer in it, has some liquid water, and then you'll notice there's some air here that also has some gaseous water, which we call water vapor, above the surface of the liquid water. And there's a manometer tube, and that manometer tube is basically measuring something that we call vapor pressure. That's the pressure of this gaseous water. Remember, pressure is caused by molecules exerting a pressure on the sides of the container. So that is these water molecules here bouncing on the sides of the container. And you can see here that we have a pressure of the container, the vapor pressure, and we have an open manometer tube that would be measuring atmospheric pressure. I have no solute in here, so this is just pure solvent. It's pure water, and it's measuring its vapor pressure. Now, one thing is that I'm going to slowly try to increase this to 100 degrees C. So I'm going to get right at 100 degrees C. 99, there's 100. Okay. And now you'll notice that the tube is of the plug of water that was here basically is gone. That's because we have boiling, and what happens is that the boiling point is equal to the vapor here, the vapor pressure here is equal to the atmospheric pressure, and we have what we call a normal boiling point. That is by definition what is the normal boiling point. When the atmospheric pressure equals the vapor pressure, water will boil, okay? Now I'm going to go back to something like here. I'm going to go back to my 25 degrees C that we had, and hopefully that plug is going to come back, and it does, okay? If I just increase this a little bit, let's say I'm going to go to like 53 degrees C. Actually, I'm going to go to about 65 degrees C. What I don't like about this animation is that there should be more water molecules here because the vapor pressure increased, and you can see that here. The pressure is actually higher. When we go to boiling, it will actually be equal to the vapor or the atmospheric pressure, and that's what does cause boiling, okay? So we're going to go back to 25 degrees C here, and I'm going to add sodium chloride, which is a solute. This is the part of colligative properties. When you add a solute to the solvent, it's going to change the way the solution behaves. And what it would change its boiling point, it will also change its freezing point. What I don't like about this animation is that this should be a different color, but sodium chloride comes from, why is there two particles? Well, you have one sodium ion and you have one chloride ion. So it would be nicer if they were different colors to differentiate that, but that's okay. Okay, so you've got your two particles, a sodium ion and a chloride ion here. Now, what happens is that when I go to, we're going to go to 65, which is what I was at before, there's actually, what's going to happen is it's called vapor pressure lowering. I don't know if you can tell here, but the vapor pressure is not the same as what it was as when I had it without the solute. So actually we're going to do that right here. I'm going to record this vapor pressure at 61 degrees. The vapor pressure is 20.22, okay? I'm going to go back to no solute, and I'm going to record the vapor pressure. And you can see that it's 20.95, so it's just slightly higher, right? Now what happens is I'm going to go back to the sodium chloride. I'm going to go to, well, actually we're going to go here to no solute, and I'm going to put the temperature, I'm going to very carefully put that temperature at 100 degrees C, and we should get to boiling, right? The water is going to start boiling. It'd be great if there was more molecules here, but the vapor pressure increased. I'm going to record that. You can see the vapor pressure was 101.32 kPa. Okay, so now I'm going to go to adding, I'm going to go back to my 25, go back lower here. I'm going to add my sodium chloride, and now I'm going to take that to 100 degrees. Nope, 98, 99, just try to get that right at 100. And look at, the water isn't boiling. That's because it lowered the vapor pressure. When vapor pressure lowers, that means you have to put more energy here in order to make this boil. Okay, that's what increases the boiling point. And so colligative properties would indicate that this has a boiling point elevation because we added a solute to this. This is a very important concept to understand, okay? That's sodium chloride. All right, so vapor pressure lowering happens. Let's take a look at what would happen if we are talking about freezing. Actually, before I talk about freezing, let me show you one other thing here. So I'm going to go back to 25 degrees C here, and I kind of wish I didn't clear this, but hopefully you guys will be able to see what I'm talking about. We'll look at sodium chloride here. We're going to do and record at 25, we'll just say we're at 65 degrees, or 61, I believe, is what we were at earlier. So we'll go back to 61. So here at 61, I'm going to record, I'm going to record the vapor pressure at 61 degrees C. Now I'm going to put no solute here. I'm going to give it a chance to stabilize. Okay, I'm going to record. Okay, so you see there's that vapor pressure lowering for when I had the sodium chloride versus no sodium chloride. But what happens if I go to calcium chloride? Now calcium chloride is CaCl2, so that has 3 particles, 1 calcium and 2 chloride. That's why there's 3. Well, what will that do to the vapor pressure? Do you think it's going to be higher than 20.22 or lower than 20.22? Let's take a look. Look at that. It's even lower than 20.22. It's about, colligative properties indicate it's about the number of particles that are in the solution that will lower the vapor pressure. Okay, so that's also an important concept to understand. Okay, so now what happens if we were to look at freezing? So we all know that water freezes at 0 degrees C. So here we go. We're going to put our water molecules here, and they will eventually slow down, hopefully. Yeah, maybe I might have to go just a little bit below. Let's just hit record. Vapor pressure is there, but let's just go a little bit slower, lower. Gotta go to -1. Okay, so there we go. We're starting to see some freezing happen in here. Okay, and just to kind of help increase this here, I'm going to go down to like a -6. Okay, so the water molecules will start freezing, and they're going to make that crystal lattice structure, and eventually they will freeze. But you know that, I'm going to just kind of help this along here and get this down. We'll bottom this out at -10 degrees C. Okay. Now, you notice that when we put a solute in here, it will increase even lower the freezing point even lower. So it doesn't increase it, it will lower the freezing point even lower. So I'm going to go to like a -6 here. Okay. And I'm going to actually put in some sodium chloride here. So we're looking at sodium chloride, and we'll just stay at that -5. And what happens, you will notice, is that the water doesn't freeze. either as quickly or as completely as it did if it was just pure water. And why that happens isn't so much about vapor pressure lowering as more as the solute actually gets in the way of allowing for the water molecules to freeze. And that's why it's called a freezing point depression. Okay, so this was just exploring the Gizmo a little bit to help you guys understand what vapor pressure is and that role of vapor pressure and understanding colligative properties. Hope that helps.